Are you trying to break into a data-related career on Azure but feeling stuck? With all the tools and data concepts to learn, it's easy to feel overwhelmed, especially if you're eyeing roles like Azure or Fabric Data Engineer. So, today we are going to give you a clear roadmap to get you started with data on cloud. We'll cover key data types like structured and unstructured data and dive into the data storage services you need to know, like SQL, Cosmos DB, and Azure Storage. We'll also talk about the different data roles, such as data engineers, analysts, and the services they use, like Synapse Analytics, Azure Data Factory, and Databricks, all to help you land that high-paying job in the data space. And this isn't just theory. This is a hands-on session with examples guided by an Azure expert to get your job ready. Also, for all the aspiring data professionals out there, we have got an exciting free live masterclass coming up on how to become Microsoft certified Azure or Fabric Data Engineer, Analyst, and Architect. It's completely free, so make sure to register through the link given in the description below. So without further ado, let's get started.
So in this free full course on data fundamentals on Azure Cloud, we'll begin with the concepts like data types. We're going to look at structured, unstructured, and semi-structured data. Then we'll look at data formats or how data is being stored. So we'll look at file type, and within file type, we'll look at delimited file, which could be a comma separated files or a new space, also JSON file, XML file type, and Blob. And then now these days, optimized formats like Avro or ORC and Parquet and these formats. We'll also look at the store types of databases, which is a relational databases or could be a non-relational databases, which is your key value pair or documents or type or column family, as well as GraphSQL as well. Once that's learned, we are going to then look at the OLTP, which is a data transactional data, as well as the analytical data, which is a OLAP. The OLTP has the ACID properties. So what those ACID properties means, we're going to look at that as well. Also then in analytical data workload, where this data is being stored and where it's being used, we'll look at that. Then we are also going to look at the different data roles, which could be a database administrator. And this is where I started back in, I think around more than 2 decades back in 2000. I started with an Oracle database administrator, then moved into data architect, and last more than a decade now working on cloud as a cloud architect, data architect, and multi-cloud as well. So you should be, whether you're transitioning from a database administrator or the different roles like data engineer, data analyst. And then later I'm going to talk about a free class. In that we're going to talk about different other roles like data architects, data managers, and data testers, and so on. So what are these different roles and what are kind of associated services from Microsoft Azure Cloud that you'll be knowing or should be knowing, like Azure SQL databases, Azure database for open source, third-party databases, or Azure Cosmos DB, as well as Azure storage accounts. Then from a data engineer's point of view or data analyst point of view, you have Azure Data Factory, which is a ETL tool, Azure Synapse Analytics. You have Azure Databricks, which is a Databricks implementation on Microsoft Azure Cloud, and Azure HD Insight, which is an open source Apache Hadoop based platform. Then from a data analyst point of view, you have Stream Analytics or Azure Stream Analytics. You also have Azure Data Explorer. Microsoft Purview is a new service being recently introduced for data governance, and then data mapping and discoverability point of view. We're going to look at that. And then also Power BI, which is for reporting, something similar to Tableau. So we'll look at these services. Then we're going to look at the relational data concepts. In that, we're going to look at the data which is stored. If you're coming from a database background, you probably already know, but if not, relational databases, which is your tables which are stored in rows and columns. We'll also look at schema, normalization, and then primary and foreign keys as well. Also, then we'll look at structured query language. This is a programming language to query your relational databases. And that's where we're going to look at the DDL, DML, and DCLs as well, different type of operations you can do on that relational databases. We'll also briefly touch base with the more advanced database objects like views, stored procedures, and indexes. Then we're going to look at non-relational data services on Microsoft Azure, like Blob, which could be a binary large object type, and its associated storage tiers like hot, cool, and archive. We'll also look at the active like Azure data lake data lake services, Azure Data Lake Services, Generation 2 services, and the differences of ADLS Gen 2 versus Blob as well. We'll also look at other types, which is Azure Files, which is a shared file system that supports protocol like SMB as well as NFS or network file share. And then also Azure Table Storage, which is a key value pair that you'll be learning. Then we are going to look at, then we'll move towards Azure Cosmos DB, and this is a very extensive, in-depth training that you're going to see. I'm going to bring a Microsoft certified expert or trainer and our own data expert. She teaches our programs inside our Microsoft Azure Data Engineering or Microsoft Data Engineering or data engineering programs as well. So we'll look at Cosmos DB associated with its APIs, which are options available, as well as then we'll move towards the fundamentals of data analytics. And in that, we are going to cover three parts, which is the data warehouse, large scale data warehouse systems, streaming versus real-time analytics, and data visualization. So probably might be familiar with, if you are aware of this data, or if not, you're going to learn these, which is a data ingestion. And then where do you store the data? Then you run analytical models and then do data visualization with tools like Power BI or Tableau and so on, and then data ingestion pipelines as well. Now, there are different services for that. You can have store in a data, Synapse Analytics, Databricks, or HG Insights, which one you're going to pick and why you're going to pick. We'll also look at data warehouse and data lake. In fact, we are working on another video where we go and create third thing, which is lake house, which is combination of data warehouse and a data lake. So that's coming on this channel soon here. We'll also look at batch versus stream processing, and you'll be working on data on both type of what these means are, and then using real-time data processing using Azure Stream Analytics, which is another service that you should be doing. And then finally, we'll go towards end of this, where we're going to look at data visualization using Power BI, where we look at the common data visualization tools like reports like table and text, bar, column, line chart, pie chart, scatter plot, what does this mean, and then map time as well. Now, this video has been taken from our Microsoft Azure Data Engineering, Data Analyst, and Data Scientist certification training, where we go deeper. This is, I think, day one of the training program, fundamentals. But then, so there might be some question answers. So there might be some talks about the program. So ignore those. But otherwise, you will have full day to see what to expect and what you need to learn as well. Now, if you want to go deeper towards end, I'm going to talk about a free class where we talk about how you can learn and including becoming a certified data engineer or data architect or data analyst. We'll talk about that, including certifications as well as the hands-on lab that you should be performing, which we'll talk about that towards end. Also, but before that, I want you to do is join this free community, WhatsApp community, which is K21Academy.com/Azure Data WA. WA stands for WhatsApp. So K21Academy.com/Azure Data WA. And you'll take to this group and join chat, and we'll open up WhatsApp, and we have hundreds and thousands of guys in this community who will be sharing more useful content on a regular basis as well. So for those who don't know me, my name is Atul. I have more than 2 decades of IT experience. The last more than a decade is on working on cloud, multi-cloud, data, cloud infrastructure, cloud and cloud native applications, helping migrating applications from on-premise to cloud. And we teach and help and upskill you to become get a higher paying job, get certified and get a high paying job. So with that, without spending too much time, let's go and straight and look at this whole free course. We are going to bring an expert, our own in-house expert. She will be talking about everything about data or this full course. Enjoy this. And also, by the way, if you have any questions, any queries, or what more you want to see, leave them under comment section as well. And I'll see you towards end.
So first of all, we are going to discuss about data. Now, what do you think is data? Right. So what is your take about data? What do you think? How can I define data rather? Information. Thank you, Gandhi. Any other input that you would like to add? Others? What do you think? What is the synonym you would give to data? Information is definitely one of it. How do you perceive data? Useful information, all right. unprocessed information. Okay, that's nice. It's a fact. That's correct. It could be a fact as well. Any other input others you want to add in on the chat window? All right. See the various information or inputs that you've given over here. It's an information which could be useful, which could be processed or unprocessed. It could be a fact, right? So all of this is data, right? These are categories of data. It could be useful or it could be some data which is stored but not useful to the business requirement. It could be unprocessed or it could be processed also. Your data can be raw as well. At the same time, when you're going to go ahead and process the data, it would still remain data, right? It could be fact. You're actually documenting something so that you can, probably reap some kind of information out of that, right? So all of these, we can term them as data. When we talk about data, it is broadly classified into 3 types. Does anybody know how we can classify data? What are the 3 types when it comes to data? It is with respect to the format of data that you have. So how do you think can we classify data? That's absolutely correct. It's structured, unstructured, and semi-structured. So that's exactly the answer which you have in the chat. So when it comes to the format of the data, it can either be saved as structured data or unstructured data or semi-structured data. It is very, very important that you first classify your data, right? So whether you're going to go ahead and act as a data analyst, data scientist, data architect, whatever is the role that you're looking forward for in future, you are revolving around data. And the first prerequisite that is mandatory for you to go ahead and do is to classify your data as to either structured, unstructured, or semi-structured. Because the reason why you need to do that is that, see here, what we had mentioned this as, it is renting tools and services, right? Now you're renting these tools and services to probably go ahead and process some data. That could be one of the job that you're looking forward for. Now, your selection of the correct tool, your selection of the correct service totally depends upon what kind of data are you dealing with. And in order to make that correct decision, it's important that you first classify your data, right? Let's understand what are the 3 types. When I say structured data, in that case, it is a very rigid structure. What do I mean by rigid structure? It is in the form of rows. It is in the form of columns, right? Your data is saved in a row column format. It is rigid. You cannot change it on the go. So let's say I have a product table that has 10 columns, all of which are information about a product. Product ID, product model, product color, product name, product category. So there are 10 different columns. In the second row, when I'm entering data, let's say my product does not have a model. My product does not belong to a particular category. In that case, I just can't skip that particular column because the structure that you have defined in advance is very rigid. You have to stick to that 10 column format which you have already defined inside your data schema, right? Classic example for this would be your tables, your SQL tables, let's say, right? The second type is unstructured data. So when it comes to unstructured data, you do not have any predefined structure as such. There is no schema at all, right? So it comes in all its diversity forms. You don't have to stick to any particular format, or you don't have to go ahead and define any data schema when it comes to unstructured data. Right? Now, can you give me some example for unstructured data? Any example that you can think of? Videos, yes, that's absolutely correct. Images, audio, videos, absolutely right. So when you talk about this kind of data, it does not have any format, right? Everything comes with its own format, right? When you talk about a video, you talk about an image, you talk about an audio file, right? All of them are different from each other. There is no particular structure, there is no particular schema that you are taking into account. And that's exactly what unstructured data means. So there is no predefined structure, right? An example for this would be your video files, audio files, your PDF files also could be unstructured data, real-time recordings, absolutely, that would be a real-time live feeding for unstructured data, right? The next one is semi-structured data. Now, what do I mean by semi-structured data? So in semi-structured data, there is no predefined format. However, you have to start with at least the basic schema. Let me give you an example. See, I told you when we were talking about structured data, if you create a table with 11 rows, whether you're entering record number 1 or you're entering record number 5 or 5,000, all of them, every individual record should have those 11 columns. But in my semi-structured data, let's say I am in a scenario where I'm going to enter my customer details in the semi-structured format. One of my customer has only one phone number. So in that case, I will have only 4 columns: ID, name of the customer, one phone number, and the address of the customer. The second row that I'm entering, that customer has 2 phone numbers. I can on the go, on the fly, add a new column. So my second row will have 5 columns, right? So I will have ID, customer name, I will have phone number 1, phone number 2, and then the address. So what is the difference over here? You are starting with a schema, but you don't have to stick to that. It is flexible, right? So you do have a structure that you have that is maintained in a semi-structured data format, but it is flexible. So when it comes to semi-structured data, you do have a flexible structure or a schema that you define. However, you don't have to stick to that, right? And examples for semi-structured would be JSON, right? So when I create a JSON file, I do have certain keys wherein I'm going to go ahead and associate values. But it does not have to be the same one for every tag that I'm creating. I can add keys on the fly. I can remove keys on the fly. Same goes with XML as well. I don't have to stick to a certain format when it comes to the XML tags, right? So these are examples of data formats where you can start off with a schema, but you don't have to stick to it as such, right? So now that we have understood about, yeah, XML files, absolutely right, Chetana. So now that we have discussed about data and its type, let's move on to our slide and let's see what we have in store over here. All right, so the first module that we're going to go ahead and see is about the fundamentals of data, in which our first lesson is going to be about the core data concepts, right? So the goal of this particular lesson is to introduce you to some fundamental high-level concepts revolving around data, okay? We already discussed what is data. So when it comes to data, it is a collection of facts, which could be in the form of numbers, it could be some description, it could be recorded based on some kind of observation as well, right? So data structures in which this particular data is organized are very, very important entities. And that is the reason why we have to be sure about which category does our data belong to, right? So until and unless you're able to classify your data as either structured, semi-structured, or unstructured, you will not be able to choose the correct tool. You will not be able to choose the correct service to cater to your data, right? So every entity, right? So each of this is one entity. So let's say this is the customer entity, right? In this case, I have the product entity. So every entity that you are creating, which is basically a storage of your data, it could be, the sales order, customer, products, which we see right now on the screen. It is a collection of attributes, right? So what is it? It is nothing but a collection of one or more attributes. When I say customer, It is a customer ID, customer name, first name, last name, email, address, etc. Right? If I come to the semi-structured format, these would be my attributes. Right? If I talk about the unstructured data, I can mark my attributes. This would be my date. This would be my tentative date of delivery. Right? This would be my customer name and such. Right? As we discussed, the three types are seen over here. Structured data, which is nothing but data that is adhering to a fixed schema and you have absolutely no control over it. Okay. Now, one of the major features of structured data is the fact that it is relational in nature. That means you can create relationships between your data, which is stored in the structured data format. Right? When it comes to semi-structured data format, it has information. It has some predefined format as we discussed, but you don't have to stick on it. But when it comes to unstructured data, there is no schema to organize the values. Right? Free form text, videos, images, audio streams are few of which we discussed. Right? How is data stored? Okay, so let's understand about the storage of data. So basically, there are multiple types of formats which you can use to store your data. It could be saved in the form of files, or it could be saved in the form of databases. Okay, so we'll see about database as we go ahead. Let's talk about the file formats first. So when I talk about data being saved as file formats, there are three different ways in which you can save them. See, ideally, when will you prefer file format? When your data is unstructured, you will prefer file format. Or let's say semi-structured, you will prefer to save it in the form of file format. But if your data is structured, if there is a relationship that can be created between them, in that case, you would prefer to save it as database, which is the second category which I'm talking about. Let's talk about the files first. So the first category that you see over here is delimited text, right? So when the data is stored in plain text format with specific delimiters, like in this case, what is the delimiter here? It is a comma, right? So there was a time where you used to call the delimited files as CSV files, comma separated values, right? So this is the value and it is separated by comma. You have name, last name, and email. So it's comma separated values. But now the delimiter need not be restricted to just comma. You can have a lot of other delimiters as well. Space delimited file, tab delimited file, colon delimited file. There are multiple characters or special characters that you can use to separate your columns. Right? And that is what your delimited text file looks like. Now, how are you separating the rows from each other? Columns we understood. Columns we are separating by using this delimiter in middle. How about the rows? In this case, what is that is separating my rows from each other? It is the new line character that is separating the rows from each other. Right? So I have two things when it comes to delimited text format. Number one is the field delimiter, which is comma in this case. Number two is the row terminator, which is my new line space in this case. Right? So if I had to show you that, we're talking about storage of data. Now here it is specifically with respect to the format. Okay. The first one or the first category is files. The second category is in the form of databases. So when it comes to file, you're intending to save either your unstructured data or your semi-structured data. Okay. These are the two categories that you will intend to save over here. Let me just put that down here. And here, what are the types that we are seeing? The first type that we saw was a delimited text file. Right? As I mentioned, what are the two factors that play an important role over here? It is one, the field delimiter, which could not just be a comma, there could be multiple other characters that are involved. And number two is the row terminator. Okay. The second one, let me go back here. Just put it down here before we go to the slide. The second one is JavaScript object notation. And that's exactly what your JSON means. Right? So your JSON files, which basically means JavaScript object notation. If I show you the format here, is the second category. So over here, you have the values in the form of key value format. It's a pair. First name Samir, last name Nadoy. Right? It's in the form of key value pairs over here. It's like a hierarchical document schema which you can use to define the data entities. And these are nothing but the objects. They have multiple attributes. Right? We already discussed. Data may have multiple attributes associated with that. Right? And the fact that it allows you to go ahead and keep it flexible makes JSON one of the most flexible format for both your structured and your semi-structured data. Okay, so let me just go back and add it here. The third one that we're going to go ahead and see is the XML format, which is nothing but your extensible markup language. Same like your delimited text file and your JavaScript object notation files, XML also lets you save unstructured data and semi-structured data. And it gives you a predefined schema. However, it is not very rigid with the schema. You can go about and have flexible tags for every single node that you're working with when it comes to XML. Right? But the increasing popularity of JSON is now put XML in a backseat. JSON has become more popular when it comes to storing unstructured or semi-structured data. Right? The next one is Blob, the Blob format. Does anybody know the full form of Blob? Yes, that's absolutely correct. It's binary large objects. Right? Just put that down here. So when it comes to a blob data storage that you're going to go ahead and look for, it is basically saved in the binary format, just like it is written in the name itself, right? So technically, all the blobs are stored in the bits, right? Now, what is the advantage of doing this? You can actually go ahead and save huge volume of data, right? And when it is open, it cannot be read by humans because it's in the form of bits. Unless and until there is an algorithm that is converting the data, you will not be able to interpret the same. All right, let's go back to the slide and see what we have in store. There you go. This is extensible markup language, and then you have Blob. Right? Now, finally, you also have the most recent ones, which are known as optimized formats. Right? See, the first four which have been mentioned over here are something that was traditionally used, right? But then the latest ones, people always prefer to use optimized formats. Now, what do I mean by optimized formats? See, nowadays data is everything, right? We know that the volume of data is increasing tremendously, right? Having said that, what is the best way to store data? Given the fact that, every organization is going digital, there is so much of data that is there. The amount of volume is, increasing at an unimaginable pace. So what is happening in this case? If you're going to stick to the traditional way of saving your data, over a period of time, there would be performance issues, right? In that case, you will have to move to more optimized formats where the same volume of data is saved. However, it is saved in such a format that it is occupying lesser space, like Avro, ORC, Parquet, etc. These are certain formats that allow you to go ahead and save the same volume of data in a more compressed format. It lets you go ahead and squeeze the data so that the final footprint of the file that you're creating is much smaller than the original format of the data storage. Right? And one of the most popular one is the Parquet format, which we'll be seeing extensively as we go ahead. Okay. Okay. So when you have data with you, structured data with you, wherein you can create relationship between your entities, in that case, you will go with the databases. Right now, what is the advantage of having getting to save your data as databases? The obvious advantage is the fact that you can create relationships between them, which by itself gives you a lot of advantages over the counterpart. When you don't have a relationship between your data, compared or versus to when you create relationship between your data, there are tons of advantages that come along with the relational model, right? So your databases can be further classified as databases that can create relationships, so relational databases, or at the same time, you can also have non-relational databases, right? So how would it work then? If I'm going to create a non-relational database, how would my entities be related to each other? Let's understand that part. So the first figure or the first diagram that you see over here, this is an example of a relational database, right? A relational database is basically used to store and query your structured data as such. It does not cater to any other type of data, right? So your data should be stored in tables which have very rigid structure, and they are going to represent entities. Like as you see on my screen right now, you have customer entity, you have product entity, then there's order entity, and then there is line item entity, right? And each entity that you can see here has a primary key associated with that. So see here, this is the customer ID, which is the primary key for my customer entity, product ID for my product entity, order number, which is for my order entity, and then I have line item. Yeah, I have like, in this case, I do not have any primary key. Now, what is going to be the advantage of this? The fact that it has a primary key inside this is going to make my task of creating the relationship between these entities much easier. Now imagine I had all this information in just one table. How would it look like? Let's say I take order table. Okay. Order number 100. Then there's the order date. There's customer 1. Now this customer email will come over here. The customer email will come here. The customer address will come over here. Right? What is the product that he purchased? That product ID will come here. The product name will come here. And then the price will come here. So my single order table where all the orders are recorded and a single record that I'm creating is getting so huge. And not only that, it is going to increase the duplicacy. The redundancy between the records is going to be enormous. And to avoid that, we are coming up with this relationship concept, right? So the keys, the primary key that you can create in every entity can be referenced in other tables as foreign keys, which is actually allowing you to reduce this task of having that one long record holding all the values, which is ultimately going to go ahead and make your table with a lot of redundant data inside it, right? And having redundant data inside your table is one of the biggest disadvantage, because eventually it's going to slow down the performance of your table. Clear? Now this is an example of relational database. There you go. Now let's talk about non-relational database. If I cannot create relationship between my data, in that case, how are my entities going to be related? Let's see that. So if you see here, this is an example of non-relational database. So basically, these are data management systems where you don't have a relational schema associated with every entity. However, you can go ahead and still connect them using the key value stores that you have. So you can see here, each record actually is consisting of a unique key. There is a unique key associated when it comes to product, but I cannot refer to that as a primary key. It's not a primary key, right? Because it's in the form of key value pair. The only difference is that you still have a column. We cannot call it as a column also because it's non-relational. You still have the key factor, which is saving the unique values, which is like a replacement to your primary key from the relational database concept, right? You still have that factor, and using this, you can go ahead and make the connections between your entities. That's the only difference. So you have that common feature between your relational and your non-relational databases, which will allow you to act as a mediator between the various entities whom you want to relate to, right? So in relational database, that common factor is going to be your primary key, whereas in non-relational databases, it's going to be your key value. Okay. So let's look at this example itself. I'll show you how we are going to create the relationship over here. So if I show you, I think we have, yeah, okay, there you go. See, now in this graph, just using the key factors over here, because in this case, I can create this relationship that you see over here, right? But in this graph, I'm still going ahead and creating the relationship between these various entities, although it is not in a visual representation. It's in the form of a graph. So Ben is reporting to Sue, who is working in so-and-so XYZ hardware. And Ben also works in this hardware. Now, there is a relationship that is there, but it is not visually seen as you can see in the case of relational database. However, it is in the form of a graph, right? So you might have seen mind map nodes, very, very similar to that. A graph where you have nodes, and these nodes are related to each other in a unidirectional method or a unidirectional format. And that unidirection is going to define the relationship between those two nodes. And that's exactly how your non-relational database works. Okay, so as we go ahead, we would actually be implementing relational database and non-relational database on Azure. And in what service can we do that? It will make it more clear. As of now, what we need to understand is when it comes to relational database, you have primary key and you have foreign key, which makes your task much more easier. But when it comes to non-relational database, you have to depend upon the key value which is there inside your data. And that key is going to go ahead and help you create this column family, which is the graph of the relationships between the entities. So while we implement this on Azure, you will see how exactly the difference is and which one is easier. Of course, relational databases is much easier and the performance is undoubtedly better when it comes to relational databases. Okay, still not clear about the importance of primary and foreign key. How do I know when a table has a foreign key? All right. So Maxine, let me give you an example on this. Just give me one moment. I take the help of a paint tool over here. Okay, let's say you have this employee table with you. Okay, so this is for the relational database. I'm giving you an example. Let's say you have a table called the employee table. Okay, wherein I have the employee ID, employee name, the salary that the employee is withdrawing, his performance in the organization. Okay, now there comes a necessity for me to go ahead and expand this table, wherein I need to bring in the department details also. In which department is that employee working? If I had to add some dummy data over here, let's say I'm just adding some dummy data. This is ABC, XYZ, DEF. There are 3 employees with so and so salary that they are withdrawing. All right. And let's say we give the performance as performance grade A, grade B, grade C. So as I discussed, now they are looking forward to go ahead and bring the department details over here as well, right? When that requirement comes, let's say I just bring in this one column, which is fine. Okay, I'm bringing in this one column. And in this one column, I can say that this person is in the admin department, this person is in the HR department, this person is in the IT department, and then it repeats. Another HR, I have another IT employee whom I have working in this particular organization, right? Now, as of now, I don't see an issue. However, I can see one thing, that there is redundancy in this. But as of now, I have only one column. It's not going to impact the performance of my table. Eventually, every department gets a head associated with the department. So where do I give that details? So head of the department will be in another column. For admin department, there is Steve who's heading it. HR department is headed by Mark. IT department is headed by Pooja. Again, HR department, again it is headed by Mark because the same person is heading the department, and I have Pooja all over again. Now you see, when I had just one column, I didn't have any issue about it. But now when I'm bringing another column, again there is redundancy, right? And this is something that, of course, can be avoided, right? Let's say tomorrow I'm going to bring in another column over here, which is with respect to the department. It's only going to make my table more and more normalized, which means I'm going to go ahead and end up having a lot of redundant data, which is definitely a big no when it comes to the performance of the data. Now that is where what I will do is I will create a different table altogether, which is going to be the department table, where I have department ID, department name, department HOD, department strength or department count, let's say, right? And now I'm just going to mention it once, department 1, 2, 3, where 1 is the admin department, okay? 2 is the HR department, and 3 is the IT department. And now I can say that the admin department is something that Steve heads, HR department is something that Mark heads, and IT department is something that Pooja heads. And even if tomorrow I'm going to have multiple columns coming over here, I don't have to worry about it. And in this case, how is it going to help my employee table? Instead of having all these details, I can just bring one column that's going to say that, hey, this is where I will mention the department of the employee, right? So now employee number 1 works in department number 1. Employee number 2 works in department number 2. Employee number 3 works in department number 1. So what happens in this case? The primary column of this particular table becomes the foreign column over here. You are connecting these two tables using a relationship. Okay. I'm sorry, I don't remember who asked the question, but I hope is it clear? Any questions that you have further? No worries. All right. So let's move ahead. All right, Maxine, that's fine. Okay. So let's talk about transactional data workloads. Okay, let's understand a scenario. Okay, imagine that there's a billing software which is being used in a supermarket, and there are everyday transactions that are going on inside the supermarket, right? So there is billing that's taking place day in and day out on an hourly basis. In fact, in every second. Okay, so we have an input, OLTP is the transactional data, and OLAP is analytical. Absolutely, that sums it all. Now, in this example that I'm telling you, right, where you have a supermarket and there is a billing software which is helping you bill all the various customers who are coming into the store, right? Now, this data which you're saving somewhere, let's say you're saving it in a database. This data is current data. What do I mean by current data? See, it's an everyday process that you're doing, right? If your transactions are currently implemented on that particular database, which means it is current data, not historical data, right? And this transactional data that you're saving in the database is in the present. And that is the reason why we refer to this data as transactional data, right? It is an everyday transaction that you're saving inside your data. And OLTP is something that will allow you to go ahead and perform operations on this transactional data that we are talking about. Okay, so OLTP, if I had to technically define that, it is like a live system, something that is currently in use, right? So where the data storage is optimized for both reading the data plus writing the data. So if you're billing somebody, you should not only be able to write the bill information in the database, you should be able to retrieve the product count, you should be able to retrieve the cost of the product, you should be able to retrieve the inventory stock on the go, right? So it is optimized in such a way that you can go ahead and perform both read as well as write operations, right? Now, this kind of data is called as OL. Let me just put my laser. Right. So this is what we're talking about. There it is optimized for both read and write, and this is nothing but your online transactional processing. Now imagine that you have a live software which is interacting with that particular database, and you are implementing very complex queries on that particular database, which is taking a lot of bandwidth and time for you to retrieve the data from there. What is going to be the side effect of it? So the side effect would be that it is going to pull down your live system. There's going to be a lag in the usage of the system because it's not able to go ahead and interact with the database, right? So you should always avoid performing such complex queries on your transactional database. Okay. Now, what is the solution for that? See, as a business unit, I would like to query my data to understand some trends. Let's say I want to understand which product was sold maximum in this store, maybe in the past 3 months, right? What was the highest, bill that was generated on an everyday basis? I want to make a statistics about that to figure out, what could be the marketing strategy that I want to implement it, right? Now, in that case, how will you implement these queries? Instead of doing it in your transactional database, you can move on to analytical database, right? So when you move on to analytical data workloads, this is where you have the historical data. It is not the current data. It is not the live data. It is historical data. You can query this as much as you want to, but you don't have to be worried about any kind of lag in your application. I hope that is clear. Okay, transactional and analytical data stores. Now, if I take you to the previous slide again, there is a mention about data in your transactional data store being ACID compliant. Now, what do I mean by ACID compliant? So, ACID compliance is one of the major features in your transactional data workloads, which stands for atomicity, consistency, isolation, and durability. Unless and until your transactions are ACID compliant, you cannot have a reliable data workload, right? So if I had to explain about each of it, basically, when I talk about atomicity, so what is an atom? Atom is like the single, most simplest individual unit of matter, right? That's exactly what our atomicity stands for over here. So every transaction that you do on your database should be like an individual single unit of work. Either everything fails or everything is successful. Let me give you an example. Let's say, you are carrying out a transaction where you're debiting amount from a certain bank account and then you're crediting it into another bank account. Okay. If at all there is a problem midway, the amount is debited, then there is a problem or power failure that we encounter, and the debit did not happen. The ideal scenario is that it should either have debited the account with that particular amount, or it should not have removed the account in the first place. It should not have debited that particular amount if it was not able to credit it inside the other account. So you are either completely successful in carrying out your transaction of debit and then credit, or if there is a problem midway, then you should go back to the previous stage where nothing has happened. It has not debited the amount at all. So that is why we call this as single unit of work. Either everything is successful or everything fails. There is no midway success. Okay. The second one is consistency. Now, what is consistency? See, when you're talking about database, there are multiple states in which it is present, right? The database state before a particular transaction is different. The database state after a particular transaction is different, right? So what they are trying to say when it comes to consistency is that the state of your database should not be unequal, which means, let's say you carry out a transaction. Whatever was the state before the transaction, it should be same as the state that you see after the transaction. If I give you the same example that we talked about before, where you are, debiting the amount from one account and then you're crediting it into another account. In that case, let's say the state of the database before you start the transaction is that in the account where you're going to go ahead and debit the amount, the total sum is, let's say, X, right? And the account in which you're going to credit is Y. After the transaction, even if X is nothing but X minus something now, Y should be Y plus that something. So there is consistency in the state, right? X, although X has been removed with certain amount from it, your Y has been credited with that. So there is a consistency in the state, which is prior to your transaction versus after your transaction. That is C for consistency. Then about isolation. See, when concurrent transactions are taking place, let's say you are performing this, debit and credit on your end. At the same time, a third party is actually checking the balance. Okay, what would happen? Let's say there are two people, one of whom is checking the balance in the sending amount and the other person is checking the balance in the receiver amount. They should be isolated from each other. That means if person one who's checking the debited account sees the amount being withdrawn already, at the same instant, the other person is also checking for the credited account, he should see the amount over there. There is no midway where one person gets to see that the amount has been removed and the other person gets to see that the amount has not been credited. No, because it should not be, if there are concurrent transactions that you're performing, they should not be interfering with each other. If you have debited from here and you're crediting it over there, even if simultaneously others are checking for the balance, it has to be isolated from each other, right? And the last one is durability. What if I debited the amount and then there is a crash, system crash, there's a system failure, right? So what would you do in that case? Will you roll back, or after the power is back, will you go ahead with the transaction? That totally depends on whether you have committed the transaction, whether the transaction which was performed while the failure occurred, was it committed or not? And if it was committed, if the transaction was succeeded, in that case, you have to make sure that your data changes are persistent. Even if there is any kind of failure, the server went down, whatever is the scenario, right? Your data changes should be persistent. And that is what we mean by de-durability. All right. I hope their asset compliance are correct. So now when we are talking about this transactional data workloads, eventually we know that this data would be sent to the analytical data workloads, right? Now, analytical workloads are typically read-only system, most of the scenarios. The reason, because you remember what I told you, you're going to save all the historical data over here. You're going to go ahead and deal with all the historical data, which is basically used only for analysis purpose. That's the whole idea of using this analytical workloads, right? So let's say, your monthly sales, your sales for the last year, sales for the last quarter, all of this becomes your analytical data store, right? Now, there are multiple ways in which you can actually save your analytical data store on Azure. Okay, so that is what we will see eventually when we are going to go ahead and discover a lot of services and tools which will allow you to save this analytical data store that we are referring to over here, right? So as you can see here, your data files may be stored in central data lake for analysis. Now, what is this data lake? So data lakes is one of those services which are common in large scale data warehousing. Okay, so you can go ahead and save very, very large volume of non-relational data inside your data lake, which we will eventually see, when we get to understand about the services and tools, right? You can also go ahead and create an ETL process or ELT process, whichever suits your business requirement, which is going to automatically copy the data from files, right? So what you're going to do, you're going to copy the data inside your OLTP data store, and from there, you would be dumping it inside your analytical data store, right? So the data in the data warehouse may be aggregated and then loaded in the OLAP module. Now, this processing that has been mentioned over here, aggregating the data, processing the data before you actually save it in your destination, which is OLAP or Cube, where are you going to carry that out? So this aggregation, this processing, which you need to imply on your current data is totally done using compute resources. See, imagine the process like this. So you're picking up data from transactional data store, which is fresh, which is raw. You want to play around with the data so that you're able to convert the data into something that is more meaningful, right? And then you're going to dump it inside your analytical data store. And for this, what is the help that you're taking? You're taking the help of an ETL or ELT process. Right? So these are various services which you can go ahead and use in order to save your analytical data store. It could be a data lake, a data warehouse, or it could be any of the Synapse services, which we will see as we go ahead. Okay. And finally, when they are inside your analytical model, whichever option you have selected, then you can go ahead and easily run complex queries on it. Remember, I told you, never run complex queries on your transactional data workloads. But when it comes to analytical data workloads, you will be able to go ahead and run any queries on this because this is not connected to any live application. And hence, you can go ahead and use it for querying and producing wonderful reports and dashboards, which are ultimately going to give you very good insights about your data. All right, I hope it's clear. All right. All right, so moving on to lesson number 2, which is about data roles and services. Okay, so there are lots of data roles which are revolving, in the market today in and around data. We are going to talk about 3 major data roles. Let's see what they are. So we are discussing about data roles. So there are 3 roles that we are going to take into priority over here. Number 1 is database administrator, data engineer, and data analyst. These are the 3 roles which we are going to lay importance on when we talk about the roles today, right? So if I take you back here, these are the 3 roles, right? So when it comes to database administrator, His job is more about being concerned with the data sources after you have uploaded the data in the data analytical store, right? So what are you going to do about the security? How about the scalability? What about the backups, the resiliency, right? If all of this is fine, how are you going to optimize the performance, right? Because data is going to be continuously uh, dumped inside that particular analytical store. So what is your workaround for the performance? How are you monitoring it? How are you going to optimize it, right? So after your data is dumped inside the analytical store, that is where the task of a database admin starts. Okay. Before that, who is in charge of data? It is the data engineer or the data analyst. So when I talk about the data engineer, remember I told you about pipelines, right? So pipelines are going to allow you to ingest the data from the data source, respective data source, into the correct resource on Azure, right? So as I mentioned, there are multiple tools and services. Which one are you going to go ahead and dump your data into will be designed in the pipeline. And that is the task of the data engineer, right? The data should not be as it is transferred. It should be cleaned and transformed before the data is passed in the analytical data store. Clear? The third one is data analyst. So when I talk about data analyst, this is the person who's going to go ahead and convert your data into beautiful insights. You're creating reports, you're creating charts, you're creating visual aids, you're creating dashboards, right? So all of this, it comes under the bucket of data analyst. Okay. Now I've been talking about, you're anyways going to use tools and services on Azure, right? You're going to rent tools and services on Azure. Let's discuss about these tools and services which are present in Azure. There you go. There's a list of all the data stores that you have on Azure, number one. And then there are the services which will allow you to do data engineering and analytics on Azure. Okay. So when I talk about the data stores, you can save your data in Azure SQL, which is a managed instance. You can save your data in Azure DB for open source, where you will be taking the help of one of these languages to query the same. It could be Cosmos DB, or you can save your semi-structured or unstructured data in Azure storage format. Now, what are these and how do you go about accessing this? We will discuss as we go ahead, right? Talking about data engineering and analytics. So for doing the processing part of it, see, these are all the places where you're going to store your data. How about processing the data? So for processing the data, remember we discussed about pipelines. So these pipelines you can create by using Azure Data Factory. Similarly, pipelines can also be created into Synapse Analytics, where Synapse Analytics is one workspace that allows you to create not just the pipelines. You can use your serverless SQL pool, Apache Spark pool, Data Explorer, and many such components inside the Synapse Analytics. Then you have Azure Databricks, which is again another powerful engine that allows you to go ahead and do data processing. And of course, you have Azure HD Insight, which is an open source platform, right? If all this that I'm talking about, data factory, Synapse Analytics, Databricks, etc., they deal with batch data. But there is also stream data that is there. So what is batch data and what is stream data? So when I talk about batch data, the data flow is not continuous, right? Let's say I'm receiving the data or the chunk of data at 11 p.m. And after that, there is no data that is received. Let's say at a regular time interval, 11:15, I have another chunk of data. Again, there's a time lag of 15 minutes, 11:30, I have another chunk of data. So this scenario where the data is sent to you block by block after a specific time delay is called as batch data. And on the contradictory to this, when you do not have any any time lag between the data that you're receiving, as soon as it is produced, it is sent across. In that case, you're dealing with streaming data. And for dealing with streaming data, you have Azure Stream Analytics, which is dedicatedly used for streaming data, right? You have Azure Data Explorer, where you can use it in order to go ahead and track the log system for real-time data analysis. You have Microsoft Purview. This is one of the recent additions on Azure. So Purview allows you to do data governance. See, imagine that you have so much of data on your tenant in Azure, but you don't know where what is saved, right? So in that case, for you to figure that out, for you to govern your data in a more responsible manner, you will use Microsoft Purview. And of course, the major part of analytics is done by Microsoft Power BI, where you'll get to go ahead and perform, or create visuals that can be shared across this particular platform. And that takes us to the end of this particular module as well. All right. The next module, which we're going to discuss about, is the fundamentals of relational data. Okay. So we already had an overview about relational data. We would see what exactly we have in store over here when it comes to the relational data concepts. Can we use Azure Data Factory to do data processing as in Databricks? And not only in pipeline. Yes, definitely. So, Mishek, one thing is that, when you're creating a pipeline, you're actually adding multiple activities, and you exclusively have an activity which will allow you to go ahead and run your Databricks notebook as well. Okay. So yes, that is possible. You can use Azure Data Factory pipeline where you're interacting with your Databricks and actually internally running one of the Databricks notebooks. All right. So here we are going to discuss about the basic concepts, data concepts oriented with relational database. So when we talk about relational tables, as the name suggests, this is where you have entities that can be related to each other. The data is stored in tables, and which the table consists of rows and columns. And as I mentioned before, every record should have the same columns, irrespective of whether it has value or not, irrespective of the fact if it is a relevant column or not. If I have a customer table where I create a schema that consists of 1, 2, 3, 7 columns in this case, you can see here Samir does not have a middle name. However, I cannot ignore the middle name column. I need to give that column, and here it has a null value. Right? So that is the feature of relational tables. Every column is also assigned with a data type, right? So my first name, middle name, last name, all of this would be of the data type text, right? If I talk about the ID, this would be in the form of a numeric value. The order date will be in the form of a date data type, right? So every column that you have in a relational table always has a data type that is assigned to it. And yes, that is the underlying principle of your model, of your data schema. Now, the idea of separating it like this, as I mentioned in that example of department and employee table, is to ensure that your tables are all normalized, right? If had that not been the case, in the same customer table, or let's take this as the main table, in the same product table, who purchased this product, I will have that customer name also, right? If the same customer has purchased other items also, I would have multiple names here. If other customers also purchased the hammer, all of that would be there. I would end up with a lot of denormalized data, which is not definitely good when it comes to your optimization of the performance. And that is the reason why normalizing it becomes one of the most essential tasks. So over here, as I mentioned before, the idea is to separate them because of the fact that you don't want to end up with redundant data. Right? So if you see the next slide, this is where we're talking about normalization. Right? And this is the example, that I was giving before. Look at this redundant data. So if I have sales data table, where I am not segregating the data, I'm not normalizing the data, see what I end up with. same customer repeated multiple times, right? The same product purchase that has been repeated multiple times, right? The only unique thing, in fact, the order number is also not unique, because in order number 1000, I have purchased multiple products, right? So when you decide that you want to normalize your data, you have to first think, separate each entity into its own table. So if I talk about sales data table, customer should be moving into customer table, product should be moving into product table, right? The order number should be moving into the line item table, and so on. So separate this the discrete attribute into its own column. You can see here, I have the customer name, address, state, all of that in just one cell, which is not a good practice. So you should go ahead and ensure that you're able to separate or segregate the discrete attributes. These are all attributes, right? This is the entity. And inside the entity, I have a collection of attributes, right? Next, uniquely identify each entity instance. And this is where your primary key comes into picture, right? So when you are going to go ahead and separate these attributes into individual entities, ensure that every row or every record is being identified as an individual record. And how are you going to do that? With the help of that unique key, which is the primary. And then, of course, you would be relating it to the other tables by using the foreign keys to link the related entities. I hope it is clear. Okay. So technically, what we can define normalization as is, it is a term wherein we are going to design a process which is minimizing the duplication of data. We are actually enforcing the data integrity. We are removing the redundant data by doing this process. Now, how are you going to manage? See, we are talking about relational tables right now. Now, we spoke about relational. See, first we spoke about, look at the sequence that we are going through. We discussed about data first. Then we discussed about types of data. Then we discussed about the services wherein you can go ahead and save this data. Having said that, that all comprises of module number 1. Module 2, we are now picking up relational tables. In relational tables, the first thing that we understood is the fact, what are the properties associated with a relational table and what should you achieve? You should normalize those tables, right? Now, how are you going to go ahead and interact with this relational database? So SQL is the answer to that question. Okay, so your structured query language is going to allow you to go ahead and interact with your relational databases and your relational tables. Okay, so the SQL standards, the queries that you have over here. So the standards which are maintained inside this particular language are defined by ANSI and ISO. Okay, see the queries. Whenever I talk about SQL query, it is classified into 3 categories. You have DDL, DCL, and DML. Now, what are these 3 categories? Let's understand that. So when I talk about data definition language, all the queries of SQL, which you can use to manage your products, these are known as DDL. When I say manage products or manage your objects, what do I mean? So when I say manage, when you create something, you're trying to create something, you're trying to edit something, you're trying to drop something, right? You're basically managing the whole resource. In this case, what is the resource that I'm talking about? It is the object. It's the tables that we are talking about, right? So whenever you're going to go ahead and manage the whole table as such, like creating it, dropping it, renaming it, altering the table. Now, when I say alter, it is with respect to any specific column, any specific data type. Then that means you are dealing with the data definition language. Second one is data control language, right? Now, these objects which we discussed about, the tables, the entities, etc., when you are working with some query, which will allow you to manage the access to these objects. Whether one can access the object. If yes, what is the role that you're giving? What is the kind of queries that he can execute? Are you denying the access for somebody? Are you revoking the access that you have given to somebody? So whenever you are dealing with managing the access to these entities, that means you're working with a query under the category data control language. And the third one is the most commonly used queries, which is data manipulation language. Right? You are going to go ahead and see, this is the most commonly used type because that's how you interact with your objects, right? You're going to create it only once. After creating, what next? Then you would use these DML queries in order to insert the data. Let's say you want to go ahead and check out the data. You want to delete it, update it, whatever is the scenario. It is a DML query that you are working with. Okay. Just go ahead. See, apart from the fact we are trying to understand when it comes to relational databases, first we understood the primary features of a relational database. You need to have it in tables. You cannot skip having any column for any particular record. We understood the fundamental features, right? After having done that, we then came across the categories of SQL queries that you have, because SQL is your medium of interacting with relational database. Apart from these, there are also certain advanced concepts that is there in a relational database. Let's understand what are they. You have three advanced database objects: views, stored procedures, and index. So let's understand that. Views, stored procedure, and index. These are the advanced database objects. So number one is a view. Now, what do I mean by a view? Any idea? Have you come across this term called as view, or any chance that you have worked with a view? I remembered in one of the introductions yesterday, one of you all have had prior experience in SQL. Apart from them, yes, that's definitely one way of describing it. Correct. Any other things that you want to add to a view? It could be a property or something that you would like to add to the fact that it's a virtual table. All right, so I think that sums it up. See, it's a okay. Data is referenced from the actual table, absolutely. So see, the idea is that let's say you have a table that is there inside your relational database. Okay. See, imagine that you have a customer entity in your database. Okay. Now, from that customer entity, there's a lot of unnecessary data, unnecessary columns, which you do not want to go ahead and query every time. So every time I don't want to end up querying a table that has 40 plus columns. What I am interested in is those creamy 10 columns, which are enough for me to go ahead and create my report. But just because of the fact that I have 40 plus columns in my customer table, every time I end up querying that particular table, whereas my area of interest lies in those creamy 10 columns that I'm talking about. What I can do is I can create a virtual table which is actually going to pull those 10 columns for me and save it within it. I can then use that view to query. What is it going to do? It's definitely going to save the turnaround time that is taking to execute any single SQL query for me. Okay. Having said that, when a view is acting like, an outer layer for you, ensuring that you're able to get rid of the unnecessary data or the columns and bring in only the ones that you actually are interested in, what are stored procedures? See, many times, if you all have come across the programming projects, in that case, what happens is when you know that a certain set of steps are going to be very, very repeatedly carried over and over again. They're going to be carried out, let's say monthly ones, weekly ones, once in a fortnight, etc. In that case, why do you have to go ahead and write that code all over again every time you want to execute that? Instead, create it as a stored procedure. It will be like a module which you can call at any point of time. What is the advantage? Reusability is the biggest advantage, right? You don't have to sit and write the code every time you need to call it. Maybe today, tomorrow, day after tomorrow also, or maybe in the same function, you want to repeatedly perform that 3 or 4 times. Need not be even separated by a timeline. You probably want to execute it, in the same um, instinct multiple times. How do you do that? How do you reduce your work? By creating it as a stored procedure. It's a predefined SQL statement or statements that can be run on demand whenever you want to. It's saving you a lot of time, effort, and it's also allowing you to perform those tasks which you want. How can you make it dynamic? Because let's say I'm doing something over here. In this case, I'm creating a stored procedure to rename a product. But every time, I'm not going to rename the same product, which you see on my screen right now. Wrench has been renamed as spanner. But when I create it as a stored procedure, I'm going to make it dynamic in nature, right? Which means you can pass your parameters, and every time you run this, you would actually be updating a new record. Okay? And the third one is index. Now, when I talk about indexes, it is more like a tree-based structure. Why do you have indexes? First of all, why do you have indexes on any table? Okay, it's a tree-based structure, which is fine. But what is the necessity of having an index? What do you think is the basic idea of having an index? Anything that comes to your mind? No idea? Is it fine if I don't have an index and I continue using my relational database without it? Definitely, easy retrieval. That's absolutely the purpose. See, let's say you read a big book and you don't have an index at all. How difficult will it be for you to retrieve the page that you left last time, right? So, whole idea of creating index is exactly the same that we have in any of our table of content or books. It is easy retrieval, which indirectly is going to go ahead and optimize the process. So it is going to help you to speed up the process and retrieve the rows by using a pointer, which means your process is going to be more optimized. All right. And by that, we come to the end of relational databases. Okay. The next one, or the next module, we're going to talk about non-relational data. Now, remember what I told you for the non-relational data over here? It is semi-structured or unstructured data. Let's understand how or what are the features which you have to save this kind of data on Azure. One of the biggest services on Azure is Azure Storage Account, which is what is going to help you to save this non-relational data in Azure. So let's discuss about the storage account. Just give me one moment. Let's open our document. So we are talking about, let me put that down here, storage account. And why are we interested in storage account right now? Because storage account is going to go ahead and help you save the non-relational database. It's going to act as your non-relational database. Right? Now, storage accounts, you have two types of storage account when it comes to Azure. Number one is the Blob storage account. And number two is ADLS Gen 2. It stands for Azure Data Lake Storage Account. So these are the two storage accounts that you can create when it comes to Azure. Okay. So what is the difference between the two of them? So the first, okay, first let me talk about the similarity. First thing, if I had to define a storage account, I can call it as a combination of compute and storage. Of course, primary idea of using a storage account, let's say, okay, let's keep it as compute because we are not using it in combination with anything else. It's just the storage accounts that we're talking about, just the Blob storage account or the ADLS Gen2 storage account that we are talking about. So it's going to be just the storage container for you, right? Now, I have two types of storage accounts that I can create. Imagine that you're saving your semi-structured or unstructured data inside this. All right. Now, when I talk about a Blob storage account, it consists of a container. Okay. And I can go ahead and save my files inside this container. The same container is available for me in my ADLS Gen2 storage account as well. Okay. And these containers are basically going to be holding my files. Similarly, I have message queues over here. And I also have message queues here also. What are message queues? So, when the kind of data that you're actually saving is in the form of messages, there is a recipient, you're sending a message to and fro between some party. In that case, you would save it as message queues, right? So it's specifically designed in order to hold the data which is generated in the form of request response or any messages as such. Okay. The next component is Azure tables. And we have the same component over here also. So when your data is in the form of key value format, remember the JSON bison format that we spoke about? When your data is in the form of key value pairs, you can go ahead and trust in the Azure tables format to go ahead and save your data. And the final one, or the final component that we have is the file share. So let's say you want to go ahead and map the hard drive of your PC to cloud. Basically you're looking forward to transfer all the data to cloud. You can do it on file share. Now, if everything is same, then what is the difference, right? As you see over here currently, I have mentioned 4 components of each of the storage account, and as per me, all of them are same. Container is there in both of them, message queues are there in both of them, Azure tables are there in both of them, and then this file share also. Then what is the difference? Why do we have 2? First thing, why do we have 2 over here? So the difference is the fact that, let me just put this down at the bottom. You can see a better view. When it comes to blob storage, over here, you cannot go ahead and have a hierarchy. It is a flat file storage. What do I mean by flat file storage or no hierarchy? See, this is one of the folders that I have. Let's say I will go into. Okay. Now, just take some random, okay, courseware. Okay. Now I have this in the form of a hierarchy, right? See, my documents is there. Inside that I have courseware, and inside that I have my courses, right? And inside each I have further details, right? So if I have to go ahead and maintain this as a single flat file, imagine how it would look like. Because there are so many courses over here, and all the data inside all these courses will end up into just one file, which is not the correct approach, right? So if you are in a scenario where it's okay to have it like that, you just have one container and you're saving all your files inside that container, that's fine. Then you can go with a blob storage account. But if that is not the scenario, if you definitely need a hierarchy, let me put that down. If you definitely are in need of a hierarchical file system, you cannot let go. Okay. That is the major difference between your Blob storage account and your ADLS Gen 2 storage account. Okay. I hope it is clear. All right. Let's go back to the slide. So we are discussing about the fundamentals of non-relational data in Azure. Okay, so let's see what we have in store over here. We're going to discuss about the fundamentals of Azure storage. Okay, so the first one, as I mentioned over here, is your Azure Blob storage. It's the storage for data as binary large objects, right? So Blob storage is actually a service that enables you to store massive amounts of unstructured data or blobs or semi-structured data inside the containers, right? These are the containers that I was talking about. A container is like an encapsulation, right? So it is going to provide you a very easy and convenient way of grouping the related data together. So you create container 1 and save the related data in that. You create container 2 and save the related data in that, and so on. The only drawback is that you cannot create a hierarchy of files. That is something which is not allowed. Okay. So you can definitely control, how many access is very, very granular. For each container, not only is the fact that you can decide, who will access my container and who will not. You can go up to the level where you will say, okay, this person is going to access my container, which means everything inside my container, but he will only be able to read. Or this person is going to access my container and he will only be able to go ahead and read and write. He cannot delete it. So that level of granularity you have when you're working with a blob storage. I hope it is clear. Okay. So your blob storages basically support 3 types of blob, as you see here on the screen, right? So there's blob, there's page blob, and then there's append blob. Okay. So your blob and append blobs are more or less similar. I'll tell you what is the difference. When it comes to blobs, it is basically handling the data as a set of blocks. Okay, and every block can vary in its size. There's no fixed size that all the blocks should format. One of them could be small, the other one could be big, and so on, up to a maximum of 100 MB, not more than that. Okay, so a blob can contain up to 50,000 blocks, as you can see here. It can contain up. So imagine with a capacity of, as mentioned over here, 190.7 terabytes. Imagine how much data can you actually save with lot of blobs created inside your Azure Blob storage. Now, the difference between your blob and your append blob is that in blob, you can add randomly a block in the middle of nowhere, which is not allowed in your append blob. The only thing is that you have to go ahead and ensure that it is appended towards the last. Okay, that's the major difference between the blob and the append blob. Page blocks, as you see over here, it is used as virtual disk storage, right? So it is going to go ahead and, as the name suggests, page blobs, right? So page blobs are going to allow you to hold a collection of pages, right? And the idea of doing it like this is so that you can go ahead and optimize the read and write that you want to perform on that particular blob. Okay. Now, one more thing that you have to remember when you're working with a storage account, how are you going to be charged? See, anybody can store data, right? Please, when we need to store the data in the hierarchical format. See, imagine that I have sales data with me. Okay. When I have sales data with me, I decide to save the data in my blob storage. So imagine that you have the sales data for the whole last decade. Okay, sales data right from 2013 up to 2023. You're saving it here in your Azure Blob storage. You cannot create any hierarchy. You're going to end up having it all in just one folder. 2013, 2014, 2015 or so on. Or even worse, you can have only a single file in it where all the data is present and then there is the year column which is segregating it, right? Now that is where your ADLS Gen2 container comes into picture, because what you can do is you can create a folder, say sales. I can enter the folder. I can create a separate folder for Q1, Q2, Q3. Then in my Q1, I can go and then I can see the sales report for month 1, month 2, month 3. Q2 will have month 4, month 5, month 6. See this organization that we're doing, right? This is very important in certain scenarios. And in those scenarios, you will choose to create a storage account which has the hierarchical format in it, which is nothing but ADLS Gen2 container. I hope it is clear. All right, perfect. Okay, so how will you be charged for this? Okay, so when I say that I'm going to be charged for this particular service, which I'm using, what is going to be the factor? Okay, what do you think should be the factor? Let's say this is a storage account that I'm talking about. According to you, what should be the factor that will decide your expenditure for using it or your bill for using this particular service? Anything that comes to your mind. Keep yourself, in the perspective of the storage account. People are actually saving the data into this. Of course, the size of the memory. Definitely, that is one of the fundamental. Apart from that, size, yes, per GB charge, how much space is used. Okay. So all the answers that we have currently is all related to the size of the data, which is definitely the primary feature. Apart from that, is there anything else? Absolutely correct. So we have an answer over here that says, how often is the blob used? Okay, so that is definitely one of the major features. Now, how do I put that? What do I mean by how often is the blob used? So your blob basically gives you 3 access tiles. What do I mean by access tiles? See, the data that you're saving here, how often are you going to interact with that data? Imagine you save the data and the data is not going to be accessed at all, right? So in that case, you can go with the archive tire because you don't need to access the data. The data is there in your blob and it is just there. And it is the cheapest mode because when it is going to be saving the data in the archive tire, at that point of time, because it is the lowest of course, the data retrieval will take a lot of time. Sometimes it might take 1 or 2 days also. But the reason or the fact that we have classified the data as archive data, we shouldn't be worried about it. So if it is taking time, it is taking time. The fact that we don't need this data currently, we have marked it as archive tire. And this is the cheapest tire that is possible, right? The second tire is what is called as the pool tire. Now see, in this particular tire, the performance is higher compared to archive tire, pool tire. The performance is definitely higher and the cost is also higher accordingly, right? So it is retrieving the data and it's giving you back the data. Of course, this may take certain hours as well. However, it is lesser. The time that you have to wait is definitely lesser than the archive storage, number one. And secondly, it would be charging you a little extra accordingly. All right. And the third one is the most expensive one, which is the hot tire, right? And this is the default one. So anytime you're looking forward to go ahead and create a storage account, look at this and decide if you want to stick to this or not, right? This is the default one. And if you have to use this tire, that means your data is something that's very important and it needs to be accessed every now and then. And of course, because you're paying, a hefty amount for this, that means you're going to go ahead and also spend a lot of hotspots. Example of pool tire. Okay. So let's say, Shweta, you are saving the bank transaction details. if I had to save the details of the last decade, in that case, I will really, I mean, I can clearly go ahead with the archive tile because there is no necessity for me to go ahead with all those transactions every now and then, right? But if I had to save the transactions of, let's say, the current academic year or current financial year, so this is something that I may require, in the month end or year end analysis. It's not that I will never ever require it. I may require it now and then. That's where, like for example, the academic performance. In that case, I will create it as a cool tire. But let's say hot tire, in that case, your everyday transactions at any point of time, you need it to be up, highly performing, and available. You will go with the hot tire. And this is the second important factor in you deciding about it. Okay. So apart from the fact that how much data is saved inside your storage account, this also plays a very important role. I hope it is clear, guys. All right. So let's move on. Yeah, thank you. All right. So as I mentioned, see here, it's going to be just one hierarchy. So inside the container, okay, I have file number 1, I have file number 2, I may have file 3, file 4, file 5. There is no way for me to go ahead and have a hierarchy which will let me go ahead and set another level of hierarchy or another level of encapsulation, you can say, right? So blobs can be organized in virtual directories, but each path is considered to be a single blob in a flat namespace. This is what I was talking about. On the other hand, in contradiction to this, we have Azure Data Lake Storage Gen 2. Now, what is this and what is the difference? As you can see the diagram over here, inside the container, I can create a directory, and inside this, I will have file 1, file 2. I can create another, let's say, directory 2 over here in which I will have file 3, file 4. Directory 4, which will have file 5, file 6, and so on. So it's allowing me to create this hierarchical structure. Okay. So you can see here, it enables the file and directory level access, control, and management. Remember, I told you, gives you very, very granular control over each file, over each resource that you're saving either inside your ADLS Gen 2 container or inside your Blob container. Okay. And one important thing, the option is called as hierarchical namespace. If you check the checkbox which says I want hierarchical namespace, automatically it will be converted as a, or it will be created as an ADLS Gen 2 container. Okay. And you have a one-way upgrade process. See, what I told you is, see, this is the blob storage, let's say. Okay. And blob stage, you do not have, there is no hierarchical namespace, right? Now, if you want to go ahead and upgrade this so that you end up creating ADLS Gen 2 container that has this kind of hierarchy support inside it, you can upgrade it. However, it is a one-way upgrade, which means you will not be able to downgrade it back to your blob storage account. Okay, it's a one-way upgrade process. All right, so let's move ahead and see what we have. So apart from the fact that you have containers, we also discussed about Azure Files as well, right? So Azure Files is essentially a way where you can create cloud-based network shares. So it's one way where you can go ahead and create a cloud-based network share, right? So it's typically a connection or typically a transaction between an on-prem system on one end, and the other end, it is a cloud-based system. So by hosting the file shares in Azure, you can actually have a lot of advantage because of the, okay, let's take a practical use. You know, you're saving a file in OneDrive and you're giving access to so many people from that, right? What is the advantage of that? The advantage that you're saving so much of hardware cost, right? Everybody is not going to go ahead and get a copy. You just have one copy in the on cloud, and from there everybody's accessing it. Number one. Number two, You're saving the maintenance overhead, right? If you had multiple copies of the file, you will have to make sure that you're saving it, maintaining it, securing it, all those multiple data sources. It is a lot of overhead, right? So it is eradicating all these extra tasks, which ideally would have been a part of any file which is on cloud. Because of the fact that you have these Azure file share system, you can just move the files from on-prem on cloud, and from there you can give the accessibility. I hope it is clear. And how do you share these files from on-prem system to cloud? There are two ways of doing it. Server message block, and then there is NFS, which stands for Network File System. Okay, so the SMB basically is something that works across Windows, Linux, Mac OS. So it is cross OS, right? However, your NFS works only on Linux and Mac OS. Only these two operating system, you will be able to go ahead and do a file share on Azure cloud. And of course, it requires a premium tier as well. And of course, this is also one of the factor that will act as a deciding factor for the account expense. Okay. How do we know where to load the file? In file share, Blob, or ADLS Gen 2? Okay, that's a good question. So see, basically, when you know that your connection or your file upload is from an on-prem system to Azure, then there's no question. It's always an Azure file share that you're looking forward for, right? On the other hand, when you know that your data which you're looking forward to store is in the form of key value pairs, in that case, you can go with the Azure table storage. When it is none of this, it's not in the key value format. It is not from your on-prem system or on-prem organization or your desktop. Then by default, you will go to the container. And the container is the one that is maximum used. Okay. Now, when it's in the form of key value columns, you don't have any primary column as such, but you can have partition and row keys. So what do I mean by partition and row keys? So you can, when I say partition your table, that means you're grouping your tables, right? So you can see here in this example, I have a table. So let's say out of these records, now these records are all related. So I will create a partition for them. Later on, I realized these records are related. I will create a partition for them. And these, any further records that I have, they are related. I will create a partition for them. So each partition will have a partition key. This is partition number 1. This is partition number 2. And this is partition number 3. Now, how do I refer to the records inside a partition? For that, I have row key, right? So in partition 1, I have row 1, row 2, and row 3. In partition number 2, I have row 4, row 5, row 6, which is just making my task of retrieving the data much more easy, because I cannot have the indexing concept over here, right? So in that case, I can go ahead and use the partition key and the row keys. Okay. So you can see here, the rows are grouped into partitions to improve the performance. The property columns are assigned a data type, and they can contain any value of that data type. The rows do not need to include the same property columns. There's no threshold as such. So you can see here, property 1, property 2. It is not a fixed or rigid schema as such. You don't have a value, you will not have that column. Okay. Okay. So in the second lesson, we're going to talk or touch base about Azure Cosmos DB. So when I talk about Cosmos DB, this is like a multi-model database. What do I mean by multi-model database as such? Your data can actually see every service that we spoke about. Your data is saved in one format in that service. However, when I talk about Cosmos database, it allows you to store data in a number of different ways. Right? Currently, it allows you to save data in 4 different ways. Okay, 4 different formats. That's one major advantage of using Cosmos DB. As you can see here, you can see the data in the form of documents, graphs, key value tables, and column family stores. That's one of the major advantages. Apart from that, how do you retrieve the data from Cosmos DB? Right? So it supports a lot of APIs which will allow you to go ahead and retrieve the data at any point of time. And that is the second biggest advantage when it comes to using Cosmos DB. Now, as I mentioned here, apart from the major advantage that Cosmos DB allows you, which is the fact that you can save the same data in multiple formats, it also gives you access to APIs, application programming interface. And the reason, or the purpose of using an API is the fact that, see, let's say you have a complicated system. Okay, there is a complicated system which allows you to enter data and retrieve the data. You do not even know what is the process that is there in this particular system. Okay, all you need to do is to enter data inside this particular system, and later you want to retrieve an output from that particular input. Okay, and for doing that, you're working on a desktop application. Okay, from this desktop app, because you don't even know what is the logic behind this particular system on cloud. Now, in your desktop application, you're going to interact with this particular system using an API. Okay, let me give you a real-time example. See, any browser that I'm browsing, okay, I give the URL, I click on enter. That is all that I know. I'm giving the URL, I'm clicking on the enter. What is happening behind the scenes? I'm not sure. I get the page which I'm searching for. So behind the scenes, there is an API which is sitting on cloud, which is only expecting the basic input parameter from you. What is the basic input parameter it's expecting? The URL. It is taking that URL and then it is sending the URL to the server, right? The server which is holding the page. And it is getting that page as the response, which it is indirectly passing to us, right? Now, this server that we are talking about is a complex workstation. We have no idea in what format the data or the request should be given, in what format is the response received. From that response, how do I just pick out the status and understand that? We have no idea. Your API is that interface, okay, which is making your task easy. You give something and it returns you something. So your interaction to that complex machine is now broken down, is now simplified with this usage of the API. Okay. Now, why are we talking about API over here? So one advantage that I mentioned about Cosmos DB, one major advantage is the fact that it is allowing you to save data into multiple formats, which is why Cosmos DB is otherwise known as multi-model database service. And the second one is to go ahead and interact with the data on residing on Cosmos DB. You can use APIs. You don't have to go ahead and interact with this Cosmos DB interface directly. Okay. So what are the APIs that it supports? There are 5 different APIs that the Cosmos DB offers. There is Core SQL API, there's MongoDB API, there's Table API, there's Cassandra API, and then there's Gremlin API. Each API supports a different format of data. Remember I told you, because it gives us multiple formats in which you can save your data. That is the whole reason why it's also giving us access to multiple APIs to interact with the same. Okay, so whatever your data is in, the data that you're trying to send or the data that you're trying to receive, depending upon the format, you will decide which API are you going to use to interact with the Cosmos DB. Right? And that is the end of the current module as well. So that takes us to the last module, which is to explore the fundamentals of data analytics. So what do I mean by analytics? So analytics is basically a systematic analysis, or let's say computational analysis of data, of statistics, right? Why do you want to do this computational analysis of statistics? So let's say you want to go ahead and discover something from the data, interpret something from the data, understand some kind of pattern from the data. Unless and until you're making this effort of doing the computational analysis of the data, you will never really figure that out, right? And you have a whole lot of services which would help you do this. All right. So see, when it comes to data analytics, what are the various things that we can do? Number one, large scale data warehousing, streaming and real-time analytics. And the most important part is data visualization, because you're looking forward to gain some kind of insight from data, right? See, the whole idea of data engineering is the fact that you are going to go ahead and read some pattern identification, some trend analysis, some report, some visual, which is going to allow you to eventually understand how has the past data, how was the past data performing, and why are you doing this? In order to go ahead and ensure that you are able to take some decision for your future. Let me give you an example. Talk about sales data. In the last year, I have lots of sales data. Statistics are there, the figures are there, but I have no clue if I want to figure out, has marketing impacted sales or not. Now, how will I figure this out? Just looking at the data is not going to give me any information. I will have to create a report showing what was the impact of marketing on sales. Create it like a bar chart, create it like a line chart, create it like a donut chart. Whatever you think will be the best in giving that information to the management, choose that and complete that. So that is how important it is for data analysis. Okay. So when it comes to large scale data warehousing, there's the process, where you ingest the data. Remember I told you ETL or ELT? You first ingest the data into your system. You process it, which means you're making data transformations or cleansing in this process. Then you know that the data is residing in your analytical store. And you have to remember, when it is in the analytical store, you're not supposed to go ahead and run heavy queries on the same, right? Now, once you've done that, you will then move to analytical data model. The very word model means that you have to ensure that there are appropriate relationships between all the entities, right? And over here, you're going to end up with analytical entities, right? Because these cubes that are created over here are all transformed, they're all processed, and you're getting the cleanest form of data. And this data, this clean data or transformed data, is going to supply, or it is going to provide itself as an input to create these beautiful visualizations. Right? Now I can look and say that, okay, when the marketing increases, the sales is increasing. Or this is where I had high marketing. So I can see a large slice of my pie chart has been given for that. Right? So you can, when it comes to data visualizations, you can actually go ahead and create reports, charts, and dashboards. Okay. Now, the first task that we discussed behind was about data ingestion, right? So when I talk about data ingestion, see, your data may come from multiple data sources, right? You never even know from where your data source is coming from. In fact, it could be inside your, see this symbol that you see over here, this is the symbol of Azure account, yeah, storage account. In fact, it could be inside your storage account itself. So from your storage account, you are giving the data as an input. Now, what is the pipeline that they mentioned over here? See here, you are performing extract, transform, or load, or you're doing extract, load, and transform, right? So when you're performing this ETL or ELT activities, you are going to go ahead and create a pipeline for the same, right? So this pipeline is going to go ahead and get the data from the data input, process the data, and then give the output data set. Okay, input data set is there, output data set is there. This is raw in format. not very clean, right? Whereas this one is the transformed and clean data. Okay. So what is going to happen intermittently between, taking the raw data and then processing it as clean data? Intermittently, you will have a list of activities in a particular sequence. Okay, there's a question in the chat. What will happen in case we don't carry out data modeling? Can we still visualize the data? Definitely, Maxim, you can visualize the data even if you're not doing data modeling. However, it will impact the accuracy of your data. So visualizing it will not be a problem, but the accuracy of the data is definitely a big question. When data modeling is not complete and at par, it will impact the accuracy and the quality of the data that you receive in your visuals. All right. So in this pipeline, I have a sequence of activities, activity 1, activity 2. Then there is a decision making where I have further branching, activity 3, activity 4, and so on. Right? These activities, each activity is performing some action on the data. Okay. See, intermittently, when I say it's performing some action on the data, it may be processing the data, it may be cleansing something from the data. Whatever is the case, you're taking the help of other services to do it. As you can see in the screen right now here, it's taking the help of SQL, Databricks, etc. in order to go ahead and perform the cleansing and the transformation. Okay. So we discussed about transactional data stores. Okay. Then we discussed about how the data is pulled from the transactional data stores and how you're going to go about creating the pipeline to transform the data. And what next? Next, you are ready to dump the data in the analytical data stores, which could be again your data lake or it could be your data warehouse. Okay. So when you're looking forward to dump this analytical data, now the case is that you have got the data, you have transformed it, you've cleansed it, your job is done, what next? So when you're looking forward to dump the data in the analytical store, in that case, you have to consider this particular scenario when there is large scale relational database. Okay. Data is denormalized for query optimization because it is the last stage after the processing. But when it comes to data lake, in this case, you have a distributed file system. Remember I told you it could be blob storage or it could be ADLS Gen 2 container. Okay. And then when you're going to save the data inside the data lake, you have multiple ways of accessing the data from there. Polybase, sorry, Polybase is one of the techniques. Using a SQL query is one of the techniques. Running a pipeline is one of the techniques. There are so many different ways in which you can actually do the same. All right. Choose an analytical data store. Now, what do I mean by this? Remember, I told you when you have data stored with you, make the wise decision which one you want to use, whether it is Azure Synapse Analytics, whether it's Azure Databricks, or whether it's Azure HD Insight. Okay. These three services will give you the analytical data store. From your transactional data store, you go pick the data and dump it inside this analytical data store. And that takes us to the end of lesson number 1. Talking about lesson number 2, streaming and real-time analytics. So in batch processing, the data is grouped and then after a time lag, it is shared. See here, it is grouped and after a time lag, it is shared. Unlike what you see in stream processing currently, it is continuous. There is no break, it is continuous. Okay. However, in spite of the fact that it is continuous, you can see here, it is written as data is processed in real time as it arrives. Okay. I hope it's clear what is batch processing, what is. So, when we are going to deal with the services, tools, etc., we'll realize for batch processing, there's another set of services and tools that are available. In fact, most of which we discussed as of now, your storage accounts, dedicated SQL, so many things that we discussed about, all of them in some way support batch processing. What about stream processing? So when it comes to stream processing, you have a new service in Azure, which is called as Azure Stream Analytics. And this is totally dedicated for processing your stream data. Okay, so when you want to process your stream data, you can exclusively use Azure Stream Analytics. It is designed so that you can get this continuous streaming data, which could be in one of these services. It could be from your data lake. It could be from one of your IoT devices. It could be from Event Hub. There are multiple services. So from this streaming data, you get the data into your Synapse, into your Stream Analytics. And from here, you are processing the data. After you process the data from here, you are then giving the data as an output into one of these services. Clear? And the one that we are focusing over here is Power BI, because we're talking about visualizations. Okay. Okay. And there you go. Once you have cleaned your data, transformed your data, and also dumped your data in the analytical store, that is where you will go to the last part, that is data visualization. Now in data visualization, Power BI is one of the major data analytical tools that you can use in order to create those dashboards, in order to create those reports, right? So what is the process that we follow over here? So Power BI basically consists of two major components. One is the desktop version and the second one is the cloud-based version. And now for what will you use the desktop version? So Power BI desktop will be used basically to gather the input. As you can see here, my input is coming from multiple data sources. It's coming from Excel, it's coming from my data lake, it's coming from SQL, it's coming from Synapse Analytics, cloud. It could be just a file on your desktop. Whatever is the scenario, I'm getting multiple data. And in my Power BI desktop, I'm going to go ahead and clean and transform that data. And once I end up with clean and transformed data, I'm going to create reports over here. Okay. When I create these reports, it's a desktop software, right? So how much ever I create the reports, it's going to be only with me. How do I share it with others? That's the whole idea, right? In that case, I can create these reports and then I can publish them on cloud, which is nothing but your Power BI cloud service. And from here, you're free to go ahead and integrate it into a website, integrate it into your Power App. You can go ahead and share it over the email. You can go ahead and pin it into dashboards and so on. Okay. And if you want to have a glimpse about how your data visualizations look like, here is a view about it. So if you want to go ahead and create it in the form of a report, you would prefer using tables and text. So this is called as a table visual and this is a card visual. Okay. If you want it more presentable in the form of a bar or a column chart, you can use a lot of charts that are available. If you want to make a comparison between values, you can use a line chart. Of course, this is also a best visual aid that will allow you to go ahead and make clear-cut comparison between different categories. You have a scatter plot, which will allow you to identify the outliers. So outliers means basically something that is not aligned with the given pattern. So let's say I have marketing over here. I can see revenue versus marketing. Okay. So as the marketing increases, the revenue is increasing. But let's say in one particular year, the marketing was high, but I ended up having less revenue. Now this becomes an outlier. It is not aligned with the current pattern. And this is called as the scatter plot. Okay. If there's something that you want to show on the map, you can always use the map visual. They have 2D map visuals, there are 3D map visuals, there are many different formats which you can use in order to show the map format. And this is a glimpse about what are the various ways in which you can visualize the data which we have, transformed, cleansed, and dealt with until this particular part.
So that was a quick glimpse from our Microsoft certified trainer and Azure expert. So if you are eager to dive deeper, we have got multiple experts guiding you through this journey, and you'll have access to all their insights. We are offering a free live masterclass where we will cover how to prepare for Fabric data engineer, architect, analyst jobs, essential Azure services like Microsoft Fabric, Azure Data Factory, Databricks, Power BI, and Azure SQL Database. We'll also guide you through key certifications like Azure Data Fundamental, Fabric Data Engineer, and many more. And also we'll follow a 3-step framework to build hands-on skills with real projects, helping you land a high-paying job in Azure Data. So the link is given in the description below. Make sure you register and don't miss this opportunity. So thanks for watching this video. We'll see you in the next video.